This video explains how to connect an ESP8266 to an HMC5883 compass module and then displays the results on a OLED display. It's one of the small 64 by 48 pixel displays. The update is 100 milliseconds, which I found to be more than adequate. There's the display been plugged into the WEMOS D1 Mini, and there it is actually in operation. You can see that X is pointing vertically at the moment. It doesn't give good results when it's not on the flat surface. There it is aligned with the compass, and you'll see good correlation between magnetic north and the display. And if you excise the compass, it will obviously track the compass direction heading. There it is through 180 degrees and displaying the angle in degrees, and obviously south, back through east, north, west. So it's a micro compass. And the 100 millisecond refresh is about as fast as it can go, though I have operated it down to about 15 milliseconds. It doesn't give any particular advantage. Okay, we're going to do a code walkthrough now. It uses the wire library. There's the Adafruit display driver. There's defining the display object. The address of the device is 3C. Note that the I2C addressing shifts the address left by 1 bit and then adds the rewrite bit. These are variables to hold the last known angle of the compass angle. These define where the compass is actually displayed in the screen, so 32 bits along, 23 bits down, and a radius of 16 pixels. Don't need it, but serial diagnostics. Set up the display. Begin the wire I2C control. D1 is the clock, D2 is the data. Inside the brackets there, D1 and D2. Makes it easier sometimes. Start communication with the 5883. Send a begin transmission to the address. Select mode register 2. Send it zeros, which is a command for continuous measurement mode. End the transmission. Wait a short while. Probably don't need that delay. And then remember the last known position. Start that process off. Important to define a 16-bit integer for X, Y and Z. I know a lot of people have been getting that wrong with this device and the ESP8266. Write the command, or select register 3, sorry, and then end the transmission, and then request 6 bytes from the device, which is X, Y and Z, and while they're available, so read the first byte and then shift it to the left by 8 bits, so effectively that lowest significant byte gets shifted into the most significant part of the X variable. Same with the least significant byte, and then exclusive all of them together, and then the 16-bit result is in X, Z and Y. Note that the order is slightly unusual with this device. Draw the compass rose. Just draw that circle with the graduations on. Get the current heading, and then work out your declination, which for me I'm at -2 degrees 20 seconds west, or 2 plus 20 over 60, 2.33 degrees, minus because I'm west. Convert that into radians, so it's minus 0.041, and define a variable called declination, assign it that value, add it to the heading, and do some correction here for change of signs and overrunning 360 degrees. So that's pretty essential. Convert the angle in radians into degrees, makes it much easier for most people to understand. Then convert to draw the compass arrow. The coordinates for the screen are unusual. X to go up, it's a minus; to go down, it's a plus, and left and right is a more conventional minus and plus. Work out the actual angle of the for the angle of the heading. Work out the angle for the to draw the arrow. Undraw the last arrow in black, so erase it. The last known position of X and Y at that position out to X and Y, and then repeat that, but actually draw the new one. Save the last X and Y values. Display the it's important to do that, otherwise it loses track. Display the current angle in the bottom left hand corner, and that's the main routine complete. I've written a function just to make drawing text easier. XY string color and text size, just a general purpose display function. Unfortunately the library doesn't contain one by default. Then draw the arrow XY from the center of the display out to the designated angle. Draw the arrow head, which is two triangles. Actually draw the arrow and then draw the arrowhead. That's what those 5 commands are doing. Draw the compass rose, which is essentially drawing a circle, and then adding in the graduations, which are drawing from the outer edge of the circle, coming in by 5%, and then drawing little markers every 22.5 degrees. Display north, south, east and west, and that's it. That's the program finished. This is how it's connected, and so it's fairly straightforward, and that completes the micro OLED compass using the ESP8266, and we spend all our time in the loop just taking a reading, displaying, and there's the end result.